So good evening one and all. I welcome you to all this today's live session pertaining to numerical methods for engineers. So today we are into the 10th week of this live session. So today's topic of discussion is ordinary differential equations, initial value problems. Yes, good evening Ghanshyam. Yeah, so I hope that we are now at the end of this course. So if you still have any doubts solving the numericals and all, you can still post on a Google forum. So you must be knowing that. Before going, so you must be knowing about me, but still as what we say SOP, I'm just letting you know about me. I am Rigbet Saman, PhD student at IIT Guwahati, and I am teaching assistant to you for this course because I am using these techniques for my research purpose. So with that introduction, so today we are at the differential equation initial value problems. So in the previous week we studied numerical integration. So numerical integration can we solved using we solved the numericals pertaining to Newton-Cotes formulas. So Newton-Cotes formulas are like formulae, if you be correct, it's plural of formula. So those were trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. I hope how to solve them is clear to you. So with using this, so what we do is we have the curve and we use the definition of area under curve, and area under curve can be so that area under curve definition is used. So trapezoidal rule means the area under curve is considered to be trapezoid and then solved. So those were all subset of this Newton-Cotes formula, and what we do is we so what we do is this curve is, if we are want to go from this point to this point, we divide it into the regions. We call it an interval, and the distance between each region is called the edge, right? So with those edge, as you increase the number of edge, the accuracy increases. So how to solve them is discussed in the previous class. Even with the same number of intervals, how you can improve the accuracy was also discussed, and that can be done using this Richardson extrapolation. So if you have result for, let's say, trapezoidal rule with two intervals and one interval, you can use the Richardson extrapolation to get the better result, and that can reduce the error in your results. Also we saw the quadrature, right? Gauss quadrature, that is different from this Newton-Cotes technique. So these all we discussed in the previous class, and that were what we were doing. We are using the area under the curve to find out the value of, let's say if this is a t and this is a y, and we were finding out the area under curve to find out the value of y of t, right? So that we were using. Now ordinary differential equation, what is the difference is, here there is t, again there is y, and then there is a function, and that function is a t comma y, or it can be written as a y of t comma y. Okay, then that function, you know the slope. You would have been given a slope of the curve, that dy by dt. Okay, and from that slope of the curve you want to find out this y of t. So here you have the slope of the curve, and from slope of the curve you want to go to the y of t. That is nothing but solving the ordinary differential equation. And IVP means you will be knowing what is the slope at y is equal t is equal to 0. So you will be knowing this slope, whatever the slope value, right? So sorry, not slope value, the function value y of 0 you must be knowing. So y at t equal to 0 you will be knowing. So you will be knowing what is the initial value, and from that, and the slope of the curve at a certain point, and from that you want to find out the value of the y at particular point. Let's say y of x naught, x, y of tn is equal to what would be asked to you. So for that there are few techniques. So these are Euler method, Runge-Kutta method, second order, Runge-Kutta fourth order method. These three methods are explicit methods. So what happens is, you would be given a dy by dt, would be some function, let's say y square plus 3t or something. For the sake of it I am telling you. And then you will be given y of 0 is equal to 4, find y of 10 is equal to what? And we would, for that, if you want to solve this using the Euler's method, in Euler's method, the Euler's method's formula goes as y of I plus 1 is equal to yi plus h of f of ti comma yi. Now what is f of ti comma yi? This is nothing but this. Okay. This is y of t is that y divided by dt is comma t comma y. Now what is significance of I? I means if you consider I is equal to 0, this will become I1 I0 h into f of t comma t1 t0 comma y0. So you know the y of y0 from here, right? This is y of 0 is equal to 4 means t0 is equal to 0, y0 is equal to 4. You know the value of y0, you know the value of t0, you know the value of y0. I will talk about h, that will also be known to you. So you know all the values and you are finding the value for the next iteration. So you are finding the value at the next instant from the values at the current instant, right? So if you know the values a priori, all the values, that is called as explicit. In the next week we will go for an implicit. In that you will find the formula would be I y plus 1 would be something t I plus 1 y I plus 1. So you are finding the value of the current instant from the information of the current instant. So we will see how to do that in the next week. But for now we are only concerned with the explicit methods. So these three methods are explicit methods. Why they are explicit? Because you are only considering, you are finding the value for the next instant from the current instant, and for that you will be knowing all the values of the equation. So you know all the values of the equation, y naught, h naught, y naught, t naught, and h. So what is h now? Now let's say you want to go from t is equal to 0. So for here what I have seen, t0 is equal to, from this equation, t0 is equal to 0, y0 is equal to 4, and y of 10 I want to ask. So t0 is equal to 0, y0 is equal to 4, and tn is equal to 10. So you want to go from t is equal to 0 to 10, and in how many steps? That's what is your h, what is the distance of the, so if you want to go from with the 5 intervals, 1 2 3 4 5, so what will the distance between the distance of the each interval? That would be 2, right? 2 4 6 8 10. So this 0 to 2 is your h. This is your h value. So h is tn minus t0 divided by number of intervals. So here t n is 10, t0 is equal to 0, h is what? This is okay. This is h, this is n, this is 5. So 10 by 2 is 5 is 2. So h is 2. So h is distance of each interval, of a length of each interval, okay? And how, so this is how you can find out from the final value, initial value divided by number of intervals. So let's, without further ado, let's solve this question. So this is your first question. Find y of 2 using Euler's method for the equation dy by dt plus 2y is equal to t cube into e raised to minus 2t. Solve for n is equal to 2, n is equal to 4, and n is equal to 8. I will show you n is equal to 2, n is equal to 4, and we will see n is equal to 8 from the Excel. Okay. You are given y naught is equal to 1. So what it is given to you? What I have told you? What we are trying to find out? Y at, what do you want to find out? Y of 2, right? So your y n is equal to 2, tn is equal to, yn is equal to what? Tn is equal to 2. So you want to find out this value at the end, this. So here in this case the n is at 2 only. Okay. Tn is equal to 2. And what you are given, t naught is equal to 0, y naught is equal to 1. So therefore, and dy by dt is equal to, so is this the correct form to, so you want, for the Euler's formula, you want f of t comma y, right? So f of t comma y can only be dy by dt. So you want to rearrange the equation in terms of dy by dt. So f of t comma y is equal to dy by dt is equal to t cube into e raised to minus 2t minus 2y. Alright. Now you know f of t comma y, you know y naught and all those. So what you want is h. So what is a is n is equal to 2, right? Therefore h is equal to tn minus t0 divided by n. Tn is what? 2, t0 2, 0 divided by n is 2. So h is equal to 1. Therefore t1 is equal to t0 plus h, that is 1. Therefore t2 is equal to t1 plus h, that is 2. Okay. So this is your setup. Now you want to solve it using the Euler's formula. Therefore from Euler's formula, What is Euler's formula? Y of I plus 1 is equal to yi plus h into f of ti comma yi. So as you go on putting I of from 0 to some value, you will get these things. So therefore for I is equal to 0, y of 1 is equal to y0 plus h f of t1 comma y1, sorry, t0 comma y0, right? You want to find out a value of 2. So first you will find the value of y1, then you will put I is equal to 1, then it will give you the equation for I2. So we will go step by step. So what is y? So you know all the values. y0 is 1 plus h is 1 into f of t0 y0, right? So you have to put into, so this is nothing but f of t0 is 0 and y0 is 1. So where there is, in this equation, where there is a t, you will put 0, and when there is a y, you will put 1. So into t cube is 0, so 0 into anything would be 0, then minus 2 into y, so 2 into minus 1, so that is 2 into, 2 into 1. So better I'll write whole thing. So first term, this t cube term would be 0 minus 2 into 1. So 1 plus, so 1 minus, so this is 1 minus 2 is equal to minus 1. Correct? Correct, right? Are you following, Dhanesham? Okay, so now you got the y1. Now for I is equal to 1, y2 would be, so you will put this into this equation. So y1 is equal to h into f of t1 comma y1. So what is this? F of t1 comma y1 is f of t1 is 1, right, and y1 is minus 1. So y1 minus 1 plus h1 into, where t would be, so 1 cube, so that is 1, e raised to minus 2 into t, that's e raised to minus 2 minus 2 into y, so y is minus 1, so e raised to minus 2 minus 2 into minus 1, right? So what will the value? So the value would be 1.1353. So this is the value you get, okay, and this was what you were asked, right? Y of 2, right? So y of 2 is nothing but y, this thing, because this will imply y1 is equal to y of t1, that is y of 1, y2 would be y of t2, that is y2. Okay, so you wanted to calculate y2, so you got the answer, but the correct answer is the true answer that I have solved. So how you solve the ordinary differential equation in the normal case is using the complementary function plus particular integral. So that is your part of your mathematics 3. But if you solve that using that and you put the value at the end of it, you will get the value to be y2 star would be 0.0915, something like that. Okay, so there is some kind of an error here, right? So if you find the error, so error would be, absolute error would be 0.0915 minus 1.1353. It would come out to be 1.0438. So it's a huge error, right? It's a huge error. So why it is happening is because we are only considering two intervals. So from 1 to 2 we are skipping down the lot of points, lot of slopes. So that is why we'll solve now using n is equal to 4, and let's say if the solution gets better or not. So what is the b part? B is n is equal to 4. So your t0 is same, that is 0, y0 is same, that is 1. Now tn is again same, that is 2, yn is y2, that is equal to, sorry, yn is not equal to y2, yn is equal to what, right? That's what you want to solve. Now n is equal to 4. Since n is equal to 4 implies h is equal to what? Tn minus t0 divided by n, right? Tn is 2, t0 is 0 divided by n. N is 4, sorry. 2 divided by 4 is 0.5. So h is 0.5. Therefore t0 is equal, t1 is t0 you already have. T1 would be t0 plus h, that is 0.5. T2 would be t1 plus h, that is 1. T3 would be t2 plus h, that is 1.5. T4 would be t3 plus h, that is 2. Okay, so therefore y1 would be y of 0.5, y2 would be y of 1, y3 would be y of 1.5, y4 would be y of 2, and that's what you want, that is y of n, right? Okay, so you have to repeat the process 4 times now. Okay, so from Euler's method or from Euler's formula, what is Euler's formula? Y of I plus 1 is equal to y of I plus h into f of ti comma yi. F of t comma y is same. Okay, so therefore what is I of 0 is for I of 0, I is equal to 0, y1 is equal to y0 plus h into f of t0 comma y0. What is t0 comma y0? F of t0 is 0, y0 is 1. So y0 is 0 plus h is, now h's value would be 0.5. So this is 0.5. So this is 0.5 into, so again this again f of t, so this equation f of t comma y. So put t is equal to 0 means first term would come to, first term is 0 minus t into 1, so the whole value is minus 2, so into minus 2. So this is minus 1. Correct? Oh, sorry. Y0's value is 1, right? Y0 value is 1. So Y0 is 1. So this will become 0 because minus 1 minus 1. This is 0. So y1 would be 0. But this is not your value, right? Y of, this is y of 0.5. Therefore, I is equal to 1 implies y2. If I is equal to 1, if you put it in this equation, y1 plus h of f of t1 comma y1. Okay, t1 is 1, sorry, t1 is not 1, t1 is 0.5. That's what we calculated first. T1 is 0.5. 0.5, so I'll write properly. So difficult for you. y1 plus h of, so what is the y1 value? Y1 value just calculated, right? 0. 0 plus h is 0.5 into f of t1 0.5 comma y1 0. So where there is a so what is the equation? F of t comma y is equal to t cube e raised to minus 2t minus 2y, right? Minus 2y. Minus 2y. So where there is y, that would be 0. So last term would be 0. And the 0.5 cube be, where is it? 0.5 into 0.5 cube into e raised to minus 2 into 0.5. So this would be 0.0229. Yeah. Now similarly find out the value of y3. I is equal to 1. I is equal to 2 implies y3 would be y2 plus h of f of t2 comma y2. So what is f of t2 is 1 rho and y2 is 0.0229. So 0.0229 plus h is 0.5 and the equation you have to put the equation's value, right? So t cube means 1 into e raised to minus 2. So e raised to minus 2 minus 2 into 0.0229. So this would be 0.0676 or 77 if you want to. This is y3. That is y3 is what? Y of 1.5. Okay. Therefore, I is equal to 3. So, y4. Now, y4 is y3 plus h of f of t3 comma y3. T3 is 2. Sorry, 1.5. This is f of 1.5 comma y3 is 0.0677. Okay, so y4 would be 0.0677 plus h, that is 0.5, into, you have to substitute this value in the function. So 1.5 cube into e raised to 2 into 1.5, that is 3t, minus 2 into 0.0677. Okay. If you do that, you will get the value. Are you following? If you are doing, then I'll just wait for 1-2 seconds. Okay. Okay, the value would come out to be 0.08401 or 840, and this is your y of 2. So this is your final value. And what I told you, y2 star is 0.0915. Therefore, error is 0.09, sorry, 15 minus 0.0840. It's in 0.0784. So first the error was in 1 point something, now error is 0.0, and that to 10 raised to minus 2. So 1.8 into 10 raised to minus 3. So error is drastically reduced just by increasing the number of intervals, right? So that was the takeaway from this question, that as you increase the number of intervals, you come closer to the actual solution, approximate solution. Okay, so this n is equal to 8, I'll show you later. You can always try using pen and paper also. So this is again just yes, I'm so sorry for that, I just had to take that call. Yeah, so we'll get back to the solving the numerical. So in the first question we talked about the Euler's method and how to solve Euler's method on the ordinary differential equation problem, and you solved it using two different interval sizes, and we saw that as you increase the number of intervals, your approximate solution becomes closer to the actual solution. Now we'll try we'll see how to solve it using a different method. The basic tenet stays the same, just the formula changes. So now in the second question, find y of 2, again the same for the equation in the q1. So I'll just write down the equation. What is f of t comma y was t cube e raised to minus 2t minus 2y, and where it came from, dy by dt plus 2y is equal to t cube e raised to minus 2t. That was your question. Okay, now he has told you to solve it using the Runge-Kutta second Heun's method. So the formula is bit different this for this method. So here he has asked you to solve for h is equal to 0.5 and h is equal to 1. So from y is equal to 0, again the initial value problem, right? So initial condition is again the same. Now from second order Heun formula. So what is that? Y of I plus 1 would be equal to yi plus not h but h by 2 k1 plus k2. Previously it was direct a function value. So now there is a k1 plus k2. So what is k1 plus k2? What is k1? It is again a constant value you find out, that is nothing but your f of ti comma yi. So that was basically was there in the last one, right? And k2 is f of ti plus h comma yi plus h into k1. So is basically average first. So this is taking divided by 2 is taking the average of k1 plus k2, right? Average of the value, that is actual function value, and the function value added with the h. So this supposedly should give the better result and a faster result than this thing, Euler's method. Okay, so these three formulas goes in tandem with each other. So now as you again put the value of I is equal to 0, 1, 2, you will get the values. So till what value you have to go, that will be decided from the value of h and what is your final value. So what is A? For h is equal to 0.5. What is t0? 0. y0? 1. Right? Tn Tn is equal to 2 and Yn is equal to what? We already know h, therefore h t1 is equal to 0, so that is t0 plus h, that is 0.5. t2 is t1 plus h, that is 1. We have to go till t is equal to 3, right? t3 is equal to t2 plus h, that is 1.5. t4 tn is equal to t3 plus h, that is 2, right? Therefore we have to go till y of 4, that would be t4. be y of t2, y1 would be y of t1. 0.5, 1. So this previous like a last one, right? But the equations are a bit different. So for I is equal to 0, what will the equation becomes? Y of 1 would be y0 plus h by 2 k1 plus k2. Therefore k1 is equal to, k1 is what? F of ti yi. So f of t0 y0. So what is f of t0 y0? F of 0 comma 1. So that is nothing but put the value of 0 comma 1 in this one. It should be minus 2, right? We have been doing it for quite a time now. So 0 into minus 2. So that is minus 2, that is your k1 value. So you put this one in the function, right? F of t comma y. Sorry. This one. F of t comma y, that is t cube e raised to minus 2t minus 2y. Then you get the value. And that is the k is equal to k1 you got. Therefore k2 is f of t0 from this, f of t0 plus h comma y0 plus h k1, t0 plus h, y0 plus h into k1. So t0 plus h is 0.5, 0 plus 0.5, right? Sorry, h is what? H is 0.5, okay. And t0, okay, 0, correct. And y0 plus, y0 is 1 plus h 0.5 into k1, that is so f of 1 of 0.5 comma 1.5 to 2 is 1, that is this is 0. Okay. So what will be the answer? You have to put the value here. 0.5 cube into e raised to 1 e raised to 1 raised to minus t. Zero 0.0459, that is your k2. Okay. So therefore y1 would be this equation. Y0 is 1, this equation, right? 1 plus h by 2 is h is 0.5 divided by 2, k1 plus k2 minus 2 plus 0.0459. Therefore y1 is 0.0559. 0.5115. Okay. So this is your y1. Similarly, now you have to proceed. I0 is equal to 1. I is equal to 1. That will imply y1 would be y2 is equal to, from the equation, y2 is equal to y1 plus h by 2. y1 plus h by 2, k1 plus k2. Therefore, now k1 would be f of t1 y1, k2 would be f of t1 plus h y1 plus h into k1. Okay. So therefore, what is k1? F of t1 is t1 is what? 1. Oh, sorry, t1 is 0.5 and y1 is 0.5515. 1 comma 0.5115. Okay. Therefore, if you put this into the equation, so e raised to minus 2 minus 2 into 0.5115. So what you will get, k1 would be minus 0.977. Okay. Therefore, k2 f of t1 plus h, right? So that is this one. t1 plus h is, t1 is 0.5, 0.5 plus 1 is 1. So this is 1. Sorry, wait a second, some mistake here. The answer is same, but your t1 value is different. So t1 is 0.5. Oh, it's correct. T1, yeah. And now f of t1, right? So t1 is 0.5 and y1 is 0.5115. So therefore the equation becomes 1 raised to 0.5 into e raised to t minus 2 into 0.5115. Then your answer is minus 0.977, that is k1, and k2 is f of t1 plus h, right? So t1 plus h is 1 because t1 is 0.5 and y1 is 0.5115 into plus h 0.5 into k1. So therefore k2 would be f of 1 comma 0.0229. So if you put the value, you will get 1 into e raised to minus 2 minus 2 into 0.229 is from your function, right? So that value would be, K2 value would be 0.0893. So now you have a K2, you have K1, you will put that into Y2 equation. So therefore Y2, now Y2 is nothing but Y of 1. Y2 is Y1 is your value 0.5115. So I'll just not repeat it, I'll just give you the final answer. So you have to put a value of Y1 plus h by 2, right? Plus h by 2 is 0.5 by 2, K1 plus K2. K1 plus K2 is these two values, this one and this one. This one and this one. So Y2 would be 0.2895. So what we did for the last difference is, we have to calculate K1, K2, and then that value you have to put into h by 2 to get the value of Y1. Similarly for Y2, K1, K2 the equation would change, but the logic is same. So as you keep on doing this, for I is equal to 2, you will get Y3 is equal to Y2 plus h, right? H by 2, yeah, h by 2. So this is the change, h by 2, this is average, K1 plus K2, and K1 is nothing but now f of T2 Y2. K2 would be f of T2 plus h. So what is that is K1 is, that is K1 would be f of T2 is nothing but T2 is 1, right? Yeah, T2 is 1 comma Y2 would be 0.2895. Okay, so you have to calculate that value. Then K2 would be f of T2 plus h, Y2 plus h into K1. So that is K2 is f of T2 plus h is 1.5 plus Y2. So Y2 value is this Y2 value 0.2895 plus h 0.5 into K1. K1 is, so you have to calculate this K1 value and put it here. So I'll just I'll give you the K1 comes out to be minus 4438. If you put it here minus 4438, you will get K2 as 0.0327. So this is your K1, this is K2. If you plug this into this equation, you will get Y3. Y3 is Y2 plus, so Y2 you already have 0.2895 plus h by 2, that is 0.5 by 2, 0.25, K1 plus K2 minus 4438 plus 0.0327. So that will come out to be 0.1868. So now you get the idea, right? So that I is equal to 3 will give you Y4, because this is I plus 1. The formula starts from I plus 1. So I is equal to 3 will give you I4 y3 plus h by 2 k1 plus k2. So y3 plus h by 2 k1 plus k2. K1 would be f of t3 y3, k2 would be f of t3 plus h y3 plus h into k1. So I will leave this part to you. The final answer after doing this, you will get y3 y4, that is y of 2 as 0.1303 003, or you can say 0.1300, 0.13, that's it. So calculate the error 0.0915 minus 0.13. So error is actually not better than previous one, right? 0.0915 minus 0.13 is minus 0.0385. Sorry, not minus. It's a mod, right? So you take the absolute value. So this is 3.8 raised to 10 raised to minus 2, and the previous one gave you the minus 4 or minus 3. So you just can't generalize that because you have done all these things, your results is better than the Euler method. Okay. Now we'll go to the last question, that is Runge-Kutta, 4th order, midpoint method. Similar setup, and what he has asked you, do it using a single application. What do you mean by single application? You are not allowed to give any intervals. So what the interval size would be, whatever in from start to end, that is your interval size in single application. That is only one iteration or one application. It is not called iteration, it is application. So t0 is 0, y0 is 1, tn is equal to 2. Since single application, n is equal to 1, therefore h is equal to tn minus t0 divided by n, that is 2 minus 0 divided by 1, that is 2. Okay, that is this thing. Therefore t1 is equal to t0 plus h, 0 plus 2 is equal to 2, implies y of 1 is equal to y of 2. So you just have to do it once, but using the RK4 method. So in RK4 method there are 4 constants. In the RK2 method there were 2 constants, k1 k2. In RK4 there are 4 constants, k1 k2 k3 k4, and you will have to plug them into the yi plus 1. So from RK4 formula, what is RK4 formula? yi plus 1 is equal to yi plus h by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay, and k1 is f of tiyi, same. There was also k1 was same. f of ti yi. Okay, change is in the k2, k3, k4. Okay, so k2 would be f of ti plus h by 2 comma yi plus h k1 by 2. K3 is f of ti plus h by 2 yi plus h k2 by 2, and k4 is f of ti plus h yi plus h k3. So it has again divided the divided the interval itself into the one single application. So we'll see, using a single application, will this give you the better result? Let's see. So here you have to understand that from 0 to 2 we are not doing any intervals. Okay, the interval remains the same, h. The formula has some averaging and those things doing itself. So here there is only one interval. The application, this thing, what I was saying in the first question, there were different intervals. Okay, so interval is only one in this case. Now for I is equal to 0, you will get y of 1 is equal to y0 plus h by 6 k1 plus 2 k2 plus 2 k3 plus k4. Okay, therefore, and k1 is what? F of t0 y0. So what is t0? F of 0 comma 1. So what is f of 0 comma 1 is minus 2. That's what we're doing from start. Okay, k2 is what? y0, sorry, not y0, k2 is y of f of t0 plus h by 2, right? t0 plus h by 2. This one, t0, sorry, not this one, this one, t0 plus h by 2 comma y0 plus h k1 by 2. So f of t0 is 0 plus 2 by 2 comma y0 is 1 plus h is 2 into k1 is minus 2 divided by 2. So this is 1, this is 1, minus 2 is equal to minus 1. So f of 1 comma minus 1. So that is e raised to 2 minus 2t minus 2 into minus 1. So the value would be k2 would be 2.1353. Okay. So we'll go into the next one, that is k3. What is k3? F of t0 plus h by 2 comma y0 plus h k2 by 2. So this is nothing but 1, that is what we solved here, right? So this is 1 comma 1 plus h is 2. 2 into k2 is 2.1353 divided by 2. So f of 1 comma 3.1353, right? So that is nothing but e raised to minus 2 minus 2 into 1.1353. Sorry, 3.1353. 3.1353. So you'll get minus 6.135. This is your K3. K1, K2, K3, now K4. K4, f of T0 plus H, Y0 plus H into K3. So f of T0, T0 is 0, 0 plus H, H is 2, that is 2, Y0 is 1, plus H is 2 into K3 minus 6.135. F of 2, 11.270. Okay. What is the value? 2 cube into e raised to 4 minus 2 into 11.270. So what the value you will get? You will get 22.68. So therefore, what is the Runge-Kutta method starts equation? This one, right? If you put y is equal to 0, y0 plus h by 6, k1 plus k2 plus 2, k1 plus 2k2 plus 2k3 plus k4. So that's what y0, y1, that is nothing but y of 2 is y0. y0 was 1, right? 1 plus h by 6, that is 2 by 6, k1. k1 was minus 1, k2 2.1353, 2 into 2.1353 plus 2k3 plus 2 into minus 6.135 plus k4, that is 22.68. So therefore y1, y of 2 is equal to, what is the answer? Answer would be 5.2268. And what was y2 star? It was 0.0915. So it establishes that it is a very far away, right? Answer is far away from the actual. So it establishes that even though the Runge-Kutta's method has averaging in it, you cannot just use it for a single application. You have to give intervals and solve it, and you increase the number of intervals, you get to the answer faster. So even if Euler's method is seems to be very primitive, it serves the purpose. But what happens is RK2 methods, you will see in the next class, there is something called stiffness and everything. In those things, these RK4 methods solve it better way. In higher, if the equation is a higher order equation or something. It does. Whenever you are trying to solve it using numerical methods for ordinary differential equation, is always good practice to have intervals more than one, and then only you will able to get the final answer, approximate final answer near to the actual solutions. So these were the questions I wanted to discuss for this session. If you have any doubts, you can just tell me right now, or you can just post it on this Google forum. So what we discussed today is our three methods, explicit methods used to solve ordinary differential equation. In ordinary differential equation, there are initial value problems, means you will be given the initial value, and from that you will try to find out the value of the function for a particular instant. So let's say here you have a slope. So ordinary differential equation is nothing but a slope of the function, and from the slopes value, so this is your f of t comma y, right? Sorry, this is your dy by dt, right? So from that you are trying to find this f of t comma y. Okay. So if you have any doubts, you still can ask me. So actually I have made a blunder here. The thing is, this is f of t comma y, and this is y of t. Okay. So from this one you are trying to find a y of t, and for a particular y of tn you will solve, you want to find out the value. So from the slope of the function you are trying to find out the value of the function for a particular instant. So that is your solving ordinary differential equations. Okay. So what I'll suggest you go through it again. If you have any doubts, just post it on Google forum. This also helps me in understanding some of the techniques or some of the questions that I might let go. So I'll just encourage you to post it on the Google forum. Even if you have it right now, while going through this question, you just can ask right now. Kansham, do you have any questions? Okay, so we will meet in the next week. Probably in the next week, I'll ask the admin people. Maybe in the next Tuesday, I will take the class for week 12, and on the subsequent Friday or Saturday, I will take the class for week 12, so that this thing would be covered in the next week. What is the final decision, I will convey to you in the next class. So for the next class, we are doing it on a Tuesday, and for the next class is a week 12. I'll let you know in the next class. Okay. Thank you for listening to me. See you. Good night.